Once you have the ability to look at the contents of your web browser's developer tools, you can see the impact that browser caching has on the performance of a website. So let's look at what that impact actually is in the context of a Chrome web browser. So the high-level point here is that browsers cache information in order to make repeated network requests faster. The problem is that sometimes the network is slow. Maybe there's a lot of congestion on the network. Maybe the resources that you want are actually physically located far away on other sides of the globe. Maybe things like domain name lookups are taking a lot of time for some reason. So a solution to speeding up the amount of time it takes, to reducing the amount of time it takes to load the resources for a web page, is to just use a copy of the resource that you recently loaded from a previous request. The idea of using a copy that you've previously requested is called using a cached copy. A cache is a term that we use in computer science in order to describe resources that you have on hand that are just copies of things that are actually out on the internet already. So that's what the browser does in order to speed up the delivery of information. Let's look at an example of this. What I've done is I've created a web page and placed it on a server. And the web page just basically consists of two things. It consists of some sample demo text, and it has a picture that happens to be very large. The scale of the picture is, something like 4,000 pixels on the side. And so when we go ahead and we type in the address for this website and we load it, we can see that it actually takes quite a long time in order to get this really big image loaded, because just the network capacity and how far away it is. See, it's a very beautiful picture of wildflowers taken in California here. And if we look at that example in the Chrome web browser with the developer tools open, and we look at the network resources that were used in loading that, we can see that rendering this page took 4.88 seconds. We can see that information down here at the bottom after the web page has already been loaded. So 4.88 seconds in order to load a web page that just has one picture on it. What is that time? Where's that time going? It comes from loading this resource. It comes from the speed of the web server, the speed of the network, the ability to actually just get the bits in place. In order to load this resource, I actually had to load two different URLs. And so the two URLs that were loaded in this case were the original URL of the web page. That was the first one. Then within this web page, there was a reference to the location of this image. And the location of that image was encoded as a separate URL. So two different URLs were needed in order to render this web page. In total, the amount of information that was transferred was 17 megabytes, and you can see that as well down here on the bottom. A small amount of it was used for the original web page, which just consisted of maybe 100 characters in a text file. The majority of it was required in order to download that image. So now what we can do within the Chrome developer tools is we can actually turn off web caching. Turn on web caching. So let's load that web page again, and you can see that it's loaded, and it's loaded very quickly. You can even, just visually see that there was a difference in the amount of time that it took to load that web page. And if you look at the timeline down in the developer tools, you can see that it was remarkably fast. And in fact, by loading this page with the cache enabled, well, how did I do that for starters? There's a little checkbox here in the developer tools that says to disable or enable the cache. Just a word here. When you're using a web browser, the cache is almost certainly on unless you've taken some measures in order to turn it off. But when the developer tools are open, the assumption is that you're using your browser in a different way. And whether or not the cache is on or off is controlled by this checkbox in the Chrome browser. Because being able to look at resources and knowing whether they're cached or not is important for debugging different kinds of problems. So in order to load this web page with the cache enabled, I had to uncheck that box so that the resources would be used from the local cache. That cache, by the way, is stored on the machine from which I am generating this web browser request. If I was generating from a mobile platform, it would be stored on the phone or the tablet. If it's a laptop, it's stored on the laptop. You can see that now, once I have enabled the cache, that rendering this web page only took 6 milliseconds, not 4.8 seconds. And that was because the resources arrived so quickly at my web page. It required still 2 different URL requests. I still had to request 2 different resources, the initial web page and then when I got that back, look for that image. But the difference is when I made that request, the browser could immediately check in its little bag of URL resources that it had standing by and say, hey, have I seen that resource recently? If I've seen it recently, here, let me just give you the cached copy I have. If it's been too long, if too much time has passed, it'll go ahead and request it again from the web server. But if you request it very soon after the first request, you'll just get back what you had before. And so remarkably, if you look and you see how much information was actually transferred over the network, you can see that 0 megabytes were transferred. Instantaneous in terms of the network transmission, because no network was needed, because all the information was already present locally. So the second time that I opened this web browser, opened this web page, it loaded remarkably fast. 6 milliseconds and 2 resources and 0 megabytes transferred. Really kind of amazing. Now let's look at a more realistic example. This is UCI's web page. It has a bunch of resources associated with it. And when we loaded this web page, we can see that it took 1.66 seconds to render. So a total of 1.66 seconds in order to get all of the resources that it had to accumulate in order to draw the web page. Not as bad as my contrived example with a really large image, but still quite a bit of time in terms of how much patience a user has waiting for a website to load up. You can also see that loading this website required 54 different URLs, combination of pictures and fonts, other sub-pages, maybe JavaScript and CSS files. And in total, 6.8 megabytes were transferred. Now, when I look at the same web page after loading it a second time with the cache, well, we can see that there's a modest improvement. It only took just over 1 second in order to render, so that's an improvement of a third, or maybe 30% or so. That's pretty good. It required loading 51 different URLs. I'm a little curious where those other 3 URLs went. I would have to look into the code a little bit more specifically to understand why there's a difference. But then finally, only 102 kilobytes were transferred, and that's significantly less than was transferred when we didn't have the information in the cache. We already saw in a previous lecture that loading the UCI web page was primarily dominated by running the JavaScript within the web page. And so the amount of time that it took to load this page wasn't hugely sped up by having the information in the cache, because once the information was delivered, whether from the internet or from a cache, the JavaScript still had to be processed. So the amount of information transferred went way down. The amount of time used to render this went modestly down. Finally, let's look at a third example. A third example, we'll look at CNN.com. CNN took quite a long time to render totally, 37 seconds to finish rendering. CNN's website is a little bit complicated to do an analysis in this way because as you leave CNN's web page open, it will continue to load new information as it refreshes its content and as it refreshes its advertisements. But if you took a reference point of about 318 different URLs, that's the point at which it looked like the web page stabilized. It actually took a total of 37 seconds in order to finish rendering. A lot of different resources, 318 different resources, a lot of them advertising content, a lot of them requiring some JavaScript to be run, and transferred a total of 5.6 megabytes. Once we enabled the cache and we reloaded that web page, it took much less time to finish rendering. It took about half as long, about 15 seconds to finish rendering, and we captured that after about 328 different URLs had been rendered. Again, as CNN will continuously load more and more content, we had to pick a point at which to use as a reference point. And the amount of information that was transferred was a little bit less, 1.2 megabytes as well. So you can see that in these 3 examples, the first one a contrived example, but the other 2 real-world examples, the browser cache makes a big difference in the amount of latency that a user experiences when loading a web page. The browser cache, when you don't have the developer tools, is enabled by default. And so you get the benefits of this behavior without having to worry about turning it on or doing anything special to your web page. So the impact is that browser caching can greatly speed up your web page rendering. There is some possible confusion, however, and this particularly impacts people who are developing web pages and in the process of trying to debug and analyze the web page that they're working with. And the confusion is this. If you're working with content on a server and you're changing it, and you're trying to evaluate your change by looking at the content in your browser, and you reload the content, you may notice that a change that you were certain you made on the server doesn't appear to be making any difference in the browser. That's possibly because your browser is using the old content, not the current content that's on the web server. So let me say that again. Because the cache uses the last known load of a particular web resource, it may be using old content. You may have changed the content on the web server and asked the browser to load that content, but instead of getting it from the web server, it's getting it from its cache. And so it's not seeing the most recent changes on the web server. Now, over time, the web browser will determine that the copy that it has is too old, and it will go out and it will get a fresh copy from your web server. But while you're developing a website, it could be beneficial to you. It could save time and confusion to open up the developer console, make sure that you have disable cache checked, and only do your development in that mode so that you're always sure to be getting the most recent changes that are present on your web browser. So basically, it can be very confusing if you're changing a web page and trying to view the results and you're using cached content. If you didn't know that was happening, it could create a lot of confusion for you during the development process. So, in summary, browsers cache the information that a user needs in order to look at the results of a rendered URL in a web page. And so, in order to make repeated network requests faster, it stores copies of the URLs locally on your hard drive, smartphone, or tablet. This is great for speed and latency in situations where the remote content isn't changing very often, but it's possible that it will show slightly outdated information. The protocols that the browser uses in order to make sure that it has the most recent content available to the user are very sophisticated and usually work well. Understanding how a browser cache works is helpful for being able to do a good job of developing web applications. Hopefully this information will help you to do a better job and a more efficient job of creating web applications in the future. Thank you very much.